Okay, welcome back. 3.4 for my Math 150 class. We're going to be talking about linear regressions. Now, linear regressions are similar to linear functions. It's the same type of principle, but we're going to start seeing something a little bit different. Okay, so we're still going to be using our calculator. So what I want us to do is go ahead and think of patterns. What's my y x doing? It's going up by 5. What's my y value doing? 20, 30, 40, 50. It's going up by 10. Okay. Remember, x L1, y L2. Now, it is linear because it's going up by 5, going up by 10. Yes. Okay. Now, my slope, just for the time being, what is my slope? Okay. So, my slope is going to be, I'm going to just put it right here. Slope is my 10 over 5. Remember, y over x, which is 2. So that's what our equation should be. So just to recap as well, what I want us to do is stat edit. So on our calculator, like what we did before, stat and edit. Go to put in your L1 and L2 values. And then once you put those in, go to stat, calc, option number 4, linear regression. Okay, at any point, like I said, you can pause it, wait, catch up, go back and review. And if you need to go back to 3.3, I would advise us to do that as well. So what do we get for our A and B? Well, my A comes out to be 2, and my B comes out to be 20. So in this case, my equation would be, my equation is y of x equals 2, because that's my slope, 2x. My 20 is positive plus 20. And all you have to do is look at the values of your table. 0 times 2 is 0, plus 20 is 20. 5 times 2 is 10. 10 plus 20 is the 30 right here. 10 times 2 is 20, plus 20 is 40. So it does work. But now I'm going to ask you to, you may be asked to plot the points. You're not plotting the equation, you're plotting the points. Okay? So 0, 20. So I'm doing 10, 20, 30, 40, 50. So 0, 20, 5, 30, 10, 40, 15, 50. And that should be a straight line. That's what linear means, straight line. Okay. What about when y of x is equals 70? And what about y of 70 equals what? Well, y of x equals 70 means we use that equation that we just found, the y equals 2x plus 20. And now I'm going to say, okay, 70 equals 2x plus 20. I'm going to subtract 20 on both sides. And I get 50 equals 2x. Divide by 2. X is 25. What about when y of 70? Well, y of 70, you actually put in 70. Y of 70, you put 70 in for x. So in this case, what I'm going to do is I'm going to say y of 70 equals 2 times 70 plus 20. 2 times 70 gives you 140 plus 20. So my answer on this case is going to be 160. Now, let's take a look at this one. Now, a side note, let me see something. A side note, what I want to talk about is, okay, the difference between linear and linear regression is I'm going to show us by the chart, and then I'm going to show you by a little bit by like a little graph. But take a look at this. My t is really my x value. That's my L1 and L2. My t value is going up by 1. But take a look at this. That's going up by 2. 7 and 12 goes up by 5. 12 and 7 goes up by 5. 17 and 23 goes up by 6. So is it linear? Absolutely not. They have to go up by the same amount. But still, if you go back and do our stat and edit, put our L1 and L2 in, and you put in, you go to stat and option number 4. So go ahead and put those in, hit pause, then come back to see what my answer is. Okay, so now once we plug those in, the L1 and L2, and we do option number 4, you should come up with an A and a B. Okay, now I'm just going to round this. I'm going to round it to 1 decimal, 4.6 and 3.6. Okay, now my equation is going to be my L2. So my L2 is my M depends on my T. So my L2 depends on my L1. So MT equals 4.6T plus 3.6. Okay? Now, here's the difference between linear and not linear, or linear regression. A linear means it's a straight line. Well, these values here, I'm going to show you this, but if you all understand what scattered plot is, so if I've got some data points and I'm just plugging them in like this, what it's going to do is it's going to take all the data and try to come up with an average to make a line. So the line may look like this. It's kind of got an upward trend. But now, another thing could be is if you actually have, that's like a downward trend, it could look like something like this, because what it's trying to do is it's trying to take the average of every point. That's what regression means. That's why these answers are going to be in decimal. Okay, so next one I'm going to do is plot. I'm going to plot these values. Okay, these are the values from the table only. Okay, so I'm going to do 0, 5. Okay, 1, 7. 1, 7 is probably right in here. Then I'm going to do 2 and 12. So there's 2. 12 is maybe right up in there. Okay, and now, so if you've noticed, I'm plotting these by the table. 3 and go up to 17. And 4 and 23. Now notice, I'm just going to show you, I want to connect these. So it's not a straight line. It's close, but it's not a straight line. Okay. Now I'm going to just give us a review on clocks and stuff, and or time, and also years, because I think on the linear regression, it's similar to exactly what we did with the linear functions on section 3.3. Okay, now just want you all to practice this. So pause this at any time. Okay, remember, this is my L1, L2. This is 0. Okay, then it's going up by 1, 2, and 3. So it means it's going up by 1. My M is going up by 150. Okay, so what I want you to do is come up with to tell me if it's linear or not. That's all I'm wanting you to do on this. So in this case, this would be linear. And you can do your stat and edit and come up with an answer. Okay. Now, what about in the second example of this. So I'm going to start off with 0, 1, 2. But now what's the next number? Well, it's the difference between 2017 and 2025, which is 8. This would actually be my L1 and L2 if we wanted to find the equation. So is this linear? Well, going up by the years, I mean, it's going up 1, 2, 3, and then it's skipping some. So you may say the years would be. I want you to think about this for a second. This is 200, that's 200, and that's 200. But the gap between this and this is 6 years. These gaps are 1 year. This would be nonlinear. Now, one other side note I want to put on here is I think in your homework assignment, and you got like say an R value. All that is the coefficient. I'm not going to go into it, but basically it's how close of a straight line, how close of it being linear is it? Well, so the R value, I'm going to show you how to put this in your calculator if it asks you the R value. So when you do your stat edit option 4 and it spits you out A and B, it's going to do an R. It's going to look like this. It may look like A equals a number, maybe 10, B equals say 20, and then I say like R squared and then an R value. Okay, that's what I'm looking at. This is the R value. So what you want to do is you want to, on your calculator, hit your second button and second and 0, and it brings up a catalog. Okay, so I want you to scroll all the way down. And you're going to hit your down arrow on your calculator to this right here. Diagnostic on. Hit enter, and that will give you your R values. Okay, thank you for listening.